Welcome, students. Today we're going to look at solving systems by substitution. So far, we have learned one way to solve systems of equations. That method is by graphing them and looking to see where the lines intersect. That is, I think, the most intuitive way of solving systems of equations because we have a picture to show us exactly what's going on. It's easy to look at it and understand what's happening. Today, we're going to learn another method. This method is going to be less work than graphing, so students generally love it, but it's a lot of what people call algebraic manipulation. It's a lot of kind of moving things around and swapping them and whatnot. And so it's less clear, usually, to people why this works. This is why we do graphing first, so you can get a visual idea of what's going on, and then we move to substitution, which is a lot faster and a lot easier. Let's take a look at an example so I can show you how this works. Let's solve the system 2x equals y and x plus y equals 6. All right. Now, we could use graphing. We could graph both of these on the same plane and look to see where they intersect, but we're going to do things a little bit differently here. We're going to use substitution, and I want to focus on this first equation here, 2x equals y. Now, we don't usually talk about what an equation means, but an equation is a statement that says that the two expressions, the left side and the right-hand side, are equal to each other. Now, in this case, we don't know the value of x and we don't know the value of y, but we do know that y has to be equal to whatever 2 times x is. Because these two have the same value, we can replace one with the other, kind of like they're twins. If you've ever seen the old movie The Parent Trap with Lindsay Lohan, you never thought you'd learn math based on Lindsay Lohan, but today's the day. In The Parent Trap, Lindsay Lohan played 2 twins, and they swapped places, and nobody realized because they look exactly the same. Now, what we can do is, wherever we see a y in the other equation, we can replace it with 2x, because these are things that have the same value. Y is the same as 2x. And so wherever we see a y, we can replace it with 2x, and no one will know that we've done anything because they're equal to each other. So in this other equation, we've got x plus y, but we said y was the same as 2x. So instead of y, I'm going to replace that with 2x. And so we've got x plus 2x equals 6. This is called substitution. We are substituting in the 2x where we have a y, and we are allowed to do this because 2x is equal to y. They represent the same quantity, so replacing one with the other doesn't change the value. Now, what this has done for us is it's now given us an equation that only has one variable, and so we can actually combine these like terms, and then we can solve for x. X plus 2x is 3x, so we have 3x equals 6, and if we divide both sides by 3, that gives us x equals 2. So we have figured out the value of x. Now, we're not finished because we know that a system of equations has a solution with an x value and we need a y value. But we can use substitution again. Now that we know the value of x equals 2, we can plug that in here to either of the original equations, actually, to figure out y. I'm going to plug it in right here. We've got 2 times x, but we know x is 2 equals y. 2 times 2 is 4, and so we end up with 4 equals y, or y equals 4. And so our solution here is x equals 2 and y equals 4. This is much less work than graphing. Right? If we had to graph, we would need to use either slope-intercept form or the intercept method. We'd have to graph both of these graphs, and we'd have to do it accurately enough so we could see where they intersect. Whereas here, we just did a couple of quick calculations, and we end up getting the answer. Let's do one more. This one's going to involve a little bit more work, but we can still use substitution. Let's solve a minus 1 equals 2b and 2a minus b equals 5. Now here we have our first example of a system of equations where the variables aren't x and y. Here we've got a and b, and so it would be a little bit harder to graph this. You'd have to choose which variable represented x and which variable represented y. But with substitution, we can solve this without worrying about any of that. Now, in the first example with substitution, it was set up really nicely because we knew that y was equal to 2x. We had one of the variables written in terms of the other right away. But here, we don't have that yet. We don't have any of the variables isolated. So we need to get a variable on its own before we can apply substitution. Now, we could, for example, try to get this b by itself, but that would be a little bit complicated. To get the b alone, we'd have to divide by 2, and then we would end up with a fraction. And we don't want a fraction, especially with substitution. We can do it, it'll work, it's just going to be a lot more complicated with the algebra. So our goal is to isolate a variable that's going to be easy to isolate. In the other equation, isolating the a is not going to be easy because, again, we're going to have to divide by 2. And isolating this b is also going to be a little bit of a pain because it is a negative b. So we're going to have to divide by -1 to get rid of that negative or do something else. The easiest variable to isolate is absolutely going to be the a in the first equation because its coefficient is 1. If we ever have a variable whose coefficient is 1, that's going to be the easiest one to isolate because we're not going to have to divide and end up with fractions or deal with negatives. So to get this a alone, we need to get rid of this 1, and we can do that by adding 1 to both sides. This gives us a equals 2b plus 1. And now, whenever we see an a in the other equation, we can replace it with 2b plus 1. So let's do that here. The other equation is 2 times a, but we know a is the same as 2b plus 1. Then minus b equals 5. I hope you see what I've done here. I've taken the a in this equation and I've replaced it with 2b plus 1 because we know that a is equal to 2b plus 1. Now that we've done this, we can distribute the 2, combine like terms, and solve for b. When we distribute that 2, that gives us 4b plus 2 minus the other b equals 5. We can then combine like terms. 4b minus b is 3b. 3b plus 2 equals 5. To get the b term alone, we subtract 2 from both sides. That gives us 3b equals 3. And to get b alone, we divide by 3, giving us b equals 1. All right. Are we finished? No, we're not finished because we only know the value of b. We've also got to figure out the value of a. So we need to substitute in this value b equals 1 to figure out what a is. We could do that in any of these equations that have a and b in them, but the easiest is going to be this one because our goal is to solve for a, and here a is isolated. So I'm going to take b equals 1 and substitute it into this equation. That gives us a equals 2 times 1 plus 1. 2 times 1 is 2, and then 2 plus 1 is 3. So we end up with a equals 3 and b equals 1, which is our final answer. There are steps that we can take anytime we want to use substitution, and I'm going to write them out for you now. You should put them in your notes so that you have them handy. All right, the steps are as follows. First, isolate any one variable. That's what we did here, getting the a by itself. Then substitute this into the other equation. We have our a equals 2b plus 1, and so in the other equation we replace a with 2b plus 1. Then we solve this new equation. When we solved, we got b equals 1. Then we can substitute this result into any equation with both variables. We chose this one. We substituted in b equals 1, and then we went through and solved for the second variable. These are the steps that you can follow to do substitution. Sometimes you won't have to do a step. Like in this first example, we didn't have to isolate any one variable because we already had one isolated. So sometimes these steps will already be done for you, but other times you will have to go through them one at a time. Now remember, when we solved via graphing, there were actually 3 possibilities. We could get a solution like y equals 4 and x equals 2. We could have parallel lines, which gave us no solution, or the 2 equations could graph to the same line, which gave us infinitely many solutions. I want you to watch the videos linked below so you can see what scenarios lead us to having no solution or infinitely many solutions.